Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Today we are going to look at a new topic, which is HITS algorithm, and this is primarily used for searching across World Wide Web and other large networks. So let's read the question first. Given is a graph. Rank the vertices of the graph in the figure using the HITS algorithm. Find the authority scores and hub scores of the vertices. Proceed for 4 iterations, or you could stop if the values converge earlier. So first we need to understand what is HITS algorithm. HITS stands for hyperlink induced topic search. So before diving into the algorithm itself, let's understand that how search engines have revolutionized the way we access information, right? So there is an algorithm which is developed by Google, which is called PageRank algorithm. So it is considered to be a cornerstone in the search engine's success. So while PageRank evaluates the importance of web pages based on the links, there is another influential algorithm that operates in this similar domain, which we are going to study today, which is HITS. So the need for such algorithm lies in the fact that after 2000s, data by the enterprises was generated in petabytes and was uploaded to the internet. Search engines have revolutionized the access to information, and Google's PageRank algorithm, as mentioned previously, is making this search simpler every day. Now coming to the HITS algorithm developed by John Klingberg, it identifies authoritative and hub-like pages. So HITS algorithm is particularly used for two kinds of pages, which are either authority pages or hub-like pages in a collection of interconnected documents. So we are not just talking about web searches, but also social networks and citation networks and more. For example, a blog telling about nearby children activities versus a website which actually belongs to a kids amusement center. So the first one, which is a blog, is what we call a hub-like page. So it contains the information that kind of redirects to the actual authority page. Now the second portion of my example, which is a website which actually contains a kids amusement center, it is the authoritative center. So there is a physical locality and it has a website attached to it, right? So then we can say that those websites are representing an authority, a business, and hub-like pages are kind of having those directories where the information is stored regarding these organizations. So the two main terms that come out of this discussion is hub scores, which are the metric to measure the ability to link to the authority nodes, and the second portion is authority scores, means a node's value as a reliable source of information. So how reliable a particular kids amusement center is, or the location's information is, that is what we say as authority scores. Similarly, for hub scores, how many such reliable authorities are mentioned in that hub page is what calculated as a metric in the hub score. Now we come to the algorithm part of HITS. So we will see that we have an iterative manner of doing the process and refining these scores until they actually converge or give significant meaning to the search. So first, all nodes are assigned an initial score of 1. Then during each iteration, a node's authority score is updated based on the hub scores linking to it. So if an authority, let's say website A, has 5 links that come from different hubs, and another website B has only 2 links coming from hubs, then we say that website A has more authoritative power or score than website B. There can be more factors that affect a website score, but just for the HITS algorithm and the elements that we have in the problem, we take the hub score and the authority score to make this algorithm work. Then a node's hub score gets updated based on the authority scores it links to. So if suppose a hub A has a net of 10 hub score, meaning that website, let's say C, D, E and F, right? So now A is a hub, not a website, and C, D, E, F are the authority websites, and their scores were 2, 2, 2 and 4. So all these combined goes to 10, which is actually the hub score for node A. That's how we calculate the hub score based on the authority scores it links to. Now let's come to the problem, and one more step in this case will be that since this is an addition process, to normalize it in each step so that we don't diverge into a very large number by the end of the algorithm, we will normalize it to make sure that they are bounded in magnitude. So now let's see the algorithm in action. So using the incoming edges, we calculate the authority scores, and then using the outgoing edges, we calculate the hub scores. So basically, if a node has 2 incoming edges, then we say that it has an authority score of 2 for the initial iteration only, right? Because in the graph, we see that all the edges are equal and only change in the direction, right? So then the authority score for A is 2 because it is linked from 2 nodes. Similarly for B it will be 2. For C it's 3 because there are 3 edges that are coming to C, right, and so on. Now if we look at the hub, so we see that A points to only one node, which is C. So let me remove this, right? Then B points to 1, which is A, and then C points also to 1 only, which is B. But if we go to D, we see that D actually points to E, B and C, right? All these 3. So the hub score for D, remember this is the hub score that we are calculating, since the nodes are coming out of D. D is kind of telling us that the information is present in E, B and C. So its hub score is 3. That's how we do the initial value assignment, then make these numbers as votes for authority just as we did, and hubs will change scores as the sum of authority scores. So we use this authority scores and derive the hub scores in the next step. So we see that A points to C, right? So A has a score of this authority node, which is 3, and 3 comes from here, right? So this is leveraged to A as in the hub score. So the hub score of A is 3. Now for B, if we look at it, B points to A and A has authority score 2, right? So it will be leveraged into B's hub score. So then B has 2. Similarly for the rest of it, if we come to D, D points to E, B and C, which sum up to 1 plus 2 plus 3, 6. So then we do like this for all the 5 nodes and then sum it up, which comes out to be 19, right? Now we have the hub scores and we have the sum. Now what we can do, we can just normalize this, which is 3 by 19, 2 by 19, 2 by 19, 6 by 19 and 6 by 19, right? So this is how we normalize. Then since now we have the hub scores, we can calculate the authority scores. So if we go, we see that authority A has been pointed to from hub E and hub B, which we can check. So A is pointed to by B and E. So both of these hub scores will get added. So 0.315 plus 0.105. Remember, when you use the hub score here, you need to take it from the normalized version from the table above, right? Then we calculate it, which comes out to be 0.42. Now for B again, if we go above, we see that B is pointed to by C and D. So then 0.42. Remember that we are only considering direct connections. If A points to D and D points to B, we will not take this as a single edge, right? Now same for C. A, E and D were pointing to the node C, so its hub score got cumulated. Same is for D and E. So if we add all these together, we get 2.257. So now we have the total as well. So what we do, we simply normalize this using the formula that we saw above, 0.42 divided by 2.257. Same is with this one, right? And so on. That is how we can normalize the scores here. So that marks the end of the first iteration. Now what we see is that we again calculate the hub scores using the authority scores we saw above, right? Since A points to C and C has authority score of 0.348, remember that we will take the normalized value and not the actual authority value, 348. And then for B, which points to A, having authority score 0.186 similarly, right? For D, if we look, it points to B, C and D. So their normalized authority scores are written here, which we sum up, and then the entire column gets the sum of 2.067. So if we just divide it, like this is equal to 0.348 by 2.067, right? So that's how we normalize it. And it's just a side note that we need to use here the normalized authority scores from iteration 1. So that is done. Now we calculate the authority scores. Similarly, again we will use the hubs that are linked to the authority to basically calculate the authority scores. So authority score equals A is pointed to by B and E, so their hub scores is added, and then we get 0.4149. Similarly for B, and then C. In C, if we check, C is pointed to by A, E and D. So all those who point to C are acting as hub for C. Therefore we got 3 numbers added here. Then we have D and E, right? Again we took the sum and then we normalized these all. So this marks the end of the second iteration of the HITS algorithm, and we know that if we are not able to find the convergence at this level, then we need to go similarly calculating the hub and authority scores alternatively till we have 4 iterations in this way. Now if we try to check the authority convergence, then we have round 1 and round 2 results with us. So we get to see this type of difference in the values from round 1 to round 2 in the authority sequence. So if the difference is less than alpha and alpha is given in the question, then we can say that the convergence is achieved and the values are no longer changing, right? But if in question the value of alpha is not given, then you can assume it on your own if that is allowed. Similarly, we check that this difference is negligible, so we stop here. But as I just explained, we can go with third and fourth iteration the exact same fashion as we have done so far. Now we check the hub score convergence. So round 1 and round 2 results, there also we see that very less difference is there. Mostly its second or third decimal place changes are happening. So the difference again here is negligible, and therefore we stop the HITS algorithm at the second iteration only. So right now what we have are the final hub scores and the authority scores, which are here and here respectively for the nodes, right? So the nodes which have high authority scores are the most trusted sources of information. So in this, if we check, the highest was C. So C is the best information source out of all 5. Similarly, if we check the hub scores, a high hub score indicates the best pointing to these references. So if we check in here, both D and E are equally very good as hub nodes out of all 5. So now, looking at the big picture, the problem that we discussed was a very simple 5 document or 5 node search space. But in reality, HITS algorithm has been used to tackle web searches that identify authoritative websites on a particular given topic. Similarly, for citations, that is evaluating academic papers based on any given citation. And third, social network analysis. So finding influential nodes in a network, which is used by marketing teams these days to find potential influencers who can find them potential leads or customers. So that's been it from my side. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.